Hello friends, let's continue with our series. For the lecture number 18, we will be learning about support vector machines. Alright, let's begin. So what is a support vector machine? An SVM stands for supports vector machine, which is a powerful supervised learning algorithm. It tries to find the best boundary, called a hyperplane, that separates different classes. How it works? SVM looks for maximum margin, the widest possible gap between classes. The points closest to the boundary are called support vectors. It can also handle nonlinear data using something called the kernel kick, which maps data to a higher dimension. Alright. So what do you understand by this? Basically, SVM looks for the maximum margin. And what is margin? It is the biggest possible gap between the classes, right? There are classes and they have their own data, and there also exists a gap that classifies or differentiates these classes, right? It creates a gap. SVM looks for the maximum margin or the maximum biggest gap between these classes. Once the gap is found, the points closest to the boundary are called support vectors. Alright, I will explain you more. These points closest to the boundary of the gap among these classes, the points which are closest to the boundary are called support vectors, right? It can also handle nonlinear data using something called the kernel trick, which maps data to a higher dimension, right? The data is being mapped to a bigger dimension, like 1D to 2D, 2D to 3D, and so on. We will be learning more about it in the future videos. For now, just try to understand the basics. So why do we use it? It is very effective when there's a clear margin of separation between classes, right? We can use it very effectively when the margin of separation between the classes is very clear, right? The gap. It also works well for both linear and non-linear data. So you can use it for the linear data. You can also use it for the non-linear data, and can be used for both classification and regression tasks. So you can use it to classify, you can use it for regression. And where exactly it's used? It is used in face detection, image recognition, text classification, and spam detection. Also bioinformatics, which is gene classification. And what are some of the limitations? The limitations are that it can be slow with large data sets. It is not ideal when there is a lot of overlapping between classes, right? When they are overlapping each other and covering each other, because it looks for the boundaries, and if you overlap, there is no boundary, right? Choosing the right kernel and parameters can be tricky. That is right. It can sometimes be hard to choose the right kernel. We will learn more about it, but for this video that would be it. I hope that you were able to understand. Thank you for watching.